This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. This is Big Data with GenAI. So, friends, in previous session, we were discussing about the transformers, and I got curious. From the certain students, and they are having certain issues in order to get the context. So I have prepared one presentation in order to provide the better details so that they will be able to understand the things properly. Let me share the presentation. Okay. So we know it very well that there are two main parts inside the transformer architecture. If we are talking about the transformer, uh, GenAI is possible because of the transformer architecture, and that is the outcome with respect to one research paper which was published in 2017. Okay, and where it was described like how the transformers will be working, or they have given the transformer architecture at that moment, but what exactly is happening inside the transformer? So we know that there are two main functions, two main parts once we are talking about the transformers. Okay, so one of the part is attention mechanism, and the main role for this part is to retain the context. Retaining the context, like say over here, Narendra Modi is the prime minister of. Okay, so we are giving this particular sentence, and we are trying to predict like prime minister of India, like we are predicting the next word. We are passing a sequence of words, and with the help of that we are assuming, or we are trying to predict the next word. That's and how it will be possible because of the transformer. So over here, these particular words, and these particular words will be converted into tokens, and those particular tokens will talk to each other, and will try to retain the context, like say minister. If I'm passing minister, so will I be able to get the output? Minister can be from India, England, or USA. It can be from any country. Okay, uh, prime minister can be from a different country. Narendra Modi, once it is able to get the information prime minister Narendra Modi and prime minister, then definitely what will be the outcome? India, right? So this is how the context is creating or providing a valuable information. Because of the single word, we will not be able to get the context. Over here, just have a look. Mhm. I will show. Okay. So, say the colorful Indian festival. What will be the outcome? Colorful Indian festival. Just can anybody tell me colorful Indian festival? Guys, are
It's
you with
holy.
me?
Holy, holy.
Yes. And how we are able to get?
With the help of
How
colorful and Indian festival.
Indian festival and colorful? Colorful can be anything. If I'm passing, say colorful, but I will not be able to get holy. But once uh, the colorful Indian festival, all of these particular things combined together, then definitely next word, what it will be? Holy. Okay. So in the same way, over here inside the attention mechanism, we are trying to retain the context. Now we are trying to get the context what is given. Okay, Narendra Modi is the prime minister of. Based upon this particular sequence of words, I will be able to predict India. So these particular words is divided into tokens, and then tokens are given to token IDs, and these particular token IDs are embedded into the vector. Okay, so embedded into the vector. I will come on to this particular point. Now, the second component inside the transformer architecture is feed forward neural network, or MLP, basically multi-layer perceptron. What it is doing, it is trying to it is trying to provide the information from the you can say external world. Okay, so what is the meaning of this? During the pre-training, we are providing huge amount of data to the GenAI model, and GenAI model will be trained on that particular data. Okay, if I'm passing this particular information like Narendra Modi is Prime Minister of, and if it is not able to fetch the information from the pre-trained model, then I will not be able to get, machine will not be able to get the outcome. It is, if it is not trained, the model will not provide the outcome. We know that somewhere in our mind, subconscious mind, this particular information is fed that Narendra Modi is the Prime Minister of India. So we are able to think, we are able to provide the outcome. Colorful Indian festival. We are able to predict Holi, but Holi is came from the stored information. Okay, stored information which is matching with the context. Okay, so the the MLP is knowing about the facts, and from those particular facts the outcome is given. So you can say providing the information from the external world, that is nothing but the data stored inside the memory. You can think in this particular way for the better understanding. Like we have trained certain data based upon the data set available, and in that particular data somewhere there is say uh, Holi is there. Holi is the colorful festival of India, something like that is there, and from there it is able to fetch the information and provide the output. So that is what uh, this particular MLP is doing. Okay, multi-layer perceptron. It is providing the information from the external world. You can think in this particular, or somewhere the information is stored. It is from that particular stored information. It will provide the outcome. Now, these particular tokens are stored inside the vector. Okay, or the tokens will be embedded into the vector. What is a vector? Vector is nothing but 1D array of element, like 1 2 3. Okay, one, that is nothing a vector. Okay, one dimensional basically. 1D array. If we talk about the matrix, so matrix is nothing but the 2D array of element, where we are having rows and columns. Say 1 2 and 2 1, that is 2 cross 2 matrix. So matrix 2D, but once if we are talking about the 3D space, just focus over here guys. If we are talking about the 3D space and we have one vector, say 2 4 and 5, and we are trying to represent this particular vector into xyz direction, then it will be 2 into x, 4 into y, and 5 into z direction. So here we are trying to know that this particular the GenAI models what we are having, those particular models are having huge uh, number of dimensions. Basically we from the from our eye we will be able to see the things in 2D and 3D, you can say space only, in 2D and 3D dimensions, but 2D and 3D dimensions are not enough in order to represent the informations what we are having. Okay, we are having huge amount of data, so with the help of 2D and 3D dimensions, we will not be able to represent all of the informations. Will not be able to get the correlation between the available informations. So just try to go through with this particular uh, image over here. What we are trying about the 2D space, okay, two dimensions, and we are having certain semantic features, say age and gender and age. And with respect to this, like infant and child is closer to each other, so what it means basically, the distance between infant and child is less, so they are having similarity. Okay, so with the help of this particular graph, what I want to show that uh, the from the dimensions, say 2D dimension, 3D dimensions, once a particular semantic feature is being represented, then based upon the distance between those features, I will be able to get the similarity. If distance is less, then definitely it shows that there is certain similarity between those particular features. Say if boy is having less distance uh, to man with respect to the woman, then I can say boy is having the similarity, uh, more similarity to men with respect to women. So so we are having the vectors, okay, and those particular vectors are represented into higher dimension. So these are nothing say but the vectors, and these particular vectors are represented into the higher dimensions. And uh, and we can have multiple features, and how many features we can have, that will be uh, that will come from the sophisticated computer models or machine learning models. We will be able to get, we will pass the entire, you can say, vocabulary, and from the vocabulary we will be able to get the number of features, like for this particular model, or in order to uh, provide the better outcome on top of this particular vocabulary, we need to have this much of the features, okay. So I just want to show over here, like once we are plotting the the semantic features onto 2D space, and once two points are similar to each other, two points are having the less distance to each other, then they show similarity. Okay, over here infant and child is having less distance, so it shows they are having similarity, like infant is more closer to child with respect to girl or boy. Moving further, uh, how to get the context rich meaning. So what I have mentioned, like inside the GenAI model, we need to have the higher dimensions, okay, and higher dimensions in order to get the context rich meaning. Okay, so inside the first component of the transformer, that is nothing but uh, uh, this attention mechanism. Okay, and the main motto of this attention mechanism is to retain the context. And if we are talking about how to get the context rich information or context rich meaning, then what we need to do? Okay, so over here, like I'm having you can say four sentences, and in these four sentences running is used. She is running around the park to train for the marathon. Okay, he is he's running a small bookstore in the city center. The movie has been running in the theater for over 3 weeks. So the running word has been utilized into these four sentences, and in each sentence the meaning of running is different, so over here this is the ongoing duration, this is relating the providing it provide over here, the running is providing the context of managing, and over here the the running is providing the context, say operating something, a business store, whatever. Okay, so the context is changed based upon the words where the running is being utilized. Okay, so over here the running is utilized into different ways. Now, now if how a machine learning model will be able to get this particular information, how it will be able to get the context. Okay, so over here, say the context will be ongoing duration, how the machine learning model will be able to uh, get the information. So these particular, how it will be possible, so these particular words what we are having will be, you can say, converted into the features. Okay, and from those like vocabulary is converted into the features, and then from those features, from those particular features, these particular words are copied, and then the values what is stored over there, that will be, that will be utilized in order to get the context. I will show you at this moment. You will think it a little bit difficult, but uh, how it is possible, say entire vocabulary, try to focus, entire vocabulary is converted into features, and those features are having certain floating point numbers based upon the pre-training phase. Now we are having a particular matrix, you can say, and from that particular matrix, you can say lookup is done with these particular words, and based upon the values that we get from the pre-trained phase, we will be able to get the context. And these pre-trained features, okay, these pre-trained features are different for each model. Over here, say the GPT-3 is having 12288 features, the BART model is having 768 features, dimensions basically. Okay, so I'm having a particular code. I just want to I just want to run this, and it is nothing but like, say Narendra Modi is the Prime Minister of India. So over here this particular code is there, a simple code, no rocket science. Just I have written the sentence like Narendra Modi is the Prime Minister of India, and I just want to get the embedding points. Okay, embedding points with respect to each and every word which is mentioned over here. Okay, so I have taken auto tokenizer. I just want to convert this into the tokens, and I just want to see the token ID. Guys, please go on mute if you're not talking. Please go on mute. Thanks. Okay, so mhm, okay, so what I have done, I have just taken the sentence like Narendra Modi is the Prime Minister of India, and I just want to see the tokens, like token IDs with respect to this sentence. And for this I'm having the auto tokenizer. I have taken I have imported auto model as well, like, or with the help of auto model I will be able to import the model. Okay, so tokenizer is auto tokenizer from pre-trained model, but base uncased model is being utilized over here, and the model is but base uncased, that is perfectly fine. And I have converted uh, the sentence into tokens. So tokens I will be having the, from this tokenizer dot tokenize, so I will be able to get tokens. Over here I'm printing the tokens, all of the tokens, and then tokens are converted into token IDs. So tokenizer dot convert underscore token to IDs. So tokens has been converted to token IDs over here, and I'm printing the token IDs as well. So with the help of this, I'm printing the tokens, I'm printing the token IDs. Now, what I will do, I'm trying to encode the sentence for the model. Okay, so inside this BERT based uncased, we are having certain special tokens like CLS and SEP. These are the tokens which are automatically added. Don't worry about this particular stuff. Like these particular tokens are automatically added. So inputs is I'm passing the sentence, okay, and I'm returning the tensors as PT, okay. Padding true, truncation is true. If we are not giving this, then also it will work. So the main motto, encoding the sentence for the model. Okay, I just want to encode the model, encode the sentence for the model. So inputs, it is it will be over here the sentence what I'm having. I will pass this particular sentence. This particular stuff we have seen in the previous session as well, like how to get the tensors, right? All of you are you able to recall? We have printed the tensors, right? How to print the tensors, guys? Are you able to recall? uh, are you with me?
Yes, sir.
Anybody? Okay.
Yes, yes.
Yes, sir. Yes.
Okay, perfect. So over here, I'm just printing the tensors. I'm trying to convert. I'm just trying to get the tensors from the sentence. Now, get the embeddings. Over here, like the inputs, what is given. So torch dot no grad, that is a function. Uh, what I'm going to use with the help of this uh, output equal to modeler, and I will pass this particular inputs over here. Just don't focus on to the code. Just try to get like what I'm going to perform over here. Don't focus about the logic and all. Okay. Just think, say over here I'm printing the tokens and token IDs. Now I just want to get the embeddings and print those particular embeddings. So over here I'm getting the embeddings, and with respect to each and every token, okay, token ID, I'm printing the embedding with the help of the for loop. So for loop, I'm passing token ID and embedding, and I will iterate with the help of token IDs. Okay, and I just want to print all of these. And just have a look over here. The tokens are Narendra, NA is a token, hash REN is a token, DRA is a token, MOD is a token, I is a token, is Prime Minister of India. These are nothing but the tokens what I'm having in this particular sentence. So this is converted into tokens. Then tokens are converted into token IDs, and this is with respect to the diagram what I have shown over here, like Narendra Modi is the Prime Minister of India. So it divided into tokens. So we are having these particular tokens. Okay. Now these particular tokens are converted into token IDs. Okay. These are nothing but the token IDs. And with respect to tokens, like it will be embedded into vector. So what embeddings? So first 5 dimensions. So over here in this particular model, okay, in this particular model, say Narendra is with respect to say Narendra, okay, this is a NA is a token. So with respect to this token and token ID, this we are having these particular embeddings, and these are nothing but the floating point numbers. Okay, so inside the BERT base, this is the BERT model, and if I want to print all the embeddings, so this NA will be having 768 embeddings. With respect to each and every token, we will be having 768 tokens. Let me show you. I just want to print all of the tokens instead of first 5, and I will change the sentence as well. Say 768 dimension for each token. Okay, and let me run this. Over here, I'm having the 5 dimensions. but at this moment it will show all the 768 tokens with respect to each and every token what I'm having. Is it running? Okay. Just have a look. Previously, we were able to see only 5 tokens. I just need to change this particular 768 dimension. I just need to write 768 dimension. Okay. So this particular part will be changed if I'm going to execute it. And over here, with respect to say India, and we are having these particular tokens. These are nothing but 768. Okay, these are nothing but 768 tokens. And what I have mentioned, like if we are having, I have taken this particular say, sentence. Okay, say India. Okay, so I have taken this particular sentence. This particular sentence first it will be converted into what? Tokens. Okay, tokens, and then token to token IDs. We have seen this, token IDs, and then token ID to word embedding. Word embeddings. So word embeddings is nothing but with respect to each and every token. Say over here, it has been taken it in this way: Narendra, REN, DRA. These are three different tokens, and MOD and I. These are the tokens, and D is another token. So with respect to each and every token, we will be having 768, 768 embeddings. Embeddings. So, so over here, if we are, we have plotted, say something in this 2D, two dimensions, okay, and at that moment, like we will be having 768 dimensions with respect to this particular NA, you can say token, we will be having 768 dimensions with respect to each and every token. And these particular embeddings are providing the context where this NA has been used. Okay, so because of these particular tokens and the embeddings what I'm having, I will be able to get the context. Okay, now you might be worried like how this particular embedding is being happening. Okay, how we are able to get these particular 768 over here. Once we have done the execution, I have written this particular code what I have executed. This is the simple code like getting the token IDs, tokens, and the embeddings, and then printing those particular embeddings. Simple code, there is no rocket science. Okay, you just need to go through and try to do the execution inside the Google Call app, and you will be able to get the outcome. Okay, CLS and SEP, these are the default, you can say, embeddings. What is there? What is available inside the BERT based model? So no worry, do not worry about that particular stuff. And in order to print like this particular embedding has been avoided, exclude CLS. So these particular uh, CLS and SEP printing has been excluded. Okay. Now, once we print this, we will be able to get, and over here we are printing the 5 dimension only, because like I will not be able to paste the snapshot over here with respect to all the dimensions, 768 dimensions. So for the better understanding, I have pasted the first 5 dimensions with respect to each and every token. Now, uh, why do we have a huge dimension? Can anybody tell me why we need to have the very high dimensions inside the GenAI for the GenAI models? Why we need to have high dimensions? Earlier we were able to work with 2D, 3D. Okay, we have heard about 7D movies and all as well, but why, inside the GenAI models, why we need to have such a high dimensions like 12288 or 768 dimensions? What is the reason for that?
To get the correct context.
to to
Yes,
ca- to catch the accurate outcome.
yes, that is nothing but to capture the correct context. Okay, so we will be having the huge data sets, and that particular huge data set will be having the complex relations. Okay, and in order to get the context, until unless we are not able to get the context, then we will not be able to provide the better performance, like understanding the language and the data generation. If you uh, uh, are mentioning, say, uh, let me take one example, say, I think before 2 months, there was a trend of giblification, giblifying the image. So probably all of us has giblified the images, uploading our photos onto chat GPT and giblified that particular image. Now, on top of that giblified image, you can do certain modifications or alteration, what I can say. Say, uh, trim the hair, uh, or the specs are not good, change the specs, convert the specs into, say, rectangular specs. So, chat gpt or the GenAI model is going to take those particular inputs, and it is going to do the modifications onto the image accordingly. Okay, and uh, if you have done, that is fine, then you will be able to get the understanding. If you have not done, then try to upload a image onto the chat gpt and try to do the giblification, and at that moment you will be able to understand that based upon our inputs, the output has been changed. And why it is able to change the output? Because it has taken the inputs which is given onto the prompt, and it has matched these particular inputs with the pre-trained embeddings. Okay, pre-trained, you can say, floating point numbers at this moment, and from there the lookup is happening, and we will be able to get the 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 correct, you can say, floating point number, and we will be able to get the context. Having focus onto the context, so we are able to, the model is able to get the context and provide the output accordingly. That's why, like, once I'm saying, say, colorful Indian festival, the model is able to predict, say, Holi. Okay, so we are having high dimensions in order to get the correct context from the given sentences, okay, or data. So in order to get the context, now, how did the embedding happens? How did the embedding happens? Mhm. it, you might be having the doubt, like, say, uh, with respect to the single token, I'm getting 768 floating point numbers. Those are nothing but the embeddings. But how did this particular embedding happen? Hmm. Although, like, I have discussed this multiple times.
Multiple.
Hmm.
Multi-layer perceptions with multi-layer perceptions embedding
No,
in.
no, no, no. Multi-layer perceptron and attention is not utilized at this moment. Okay, we are talking about embeddings. We have not gone to the attention mechanism. At this moment, say we are having one sentence or multiple sentences, whatever. Okay, and we are trying to convert into embeddings. Just have a look onto this particular diagram. Let me show. Okay, this is transformer architecture. So Narendra Modi is the Prime Minister of India. Guys, are you able to see?
Yes, sir.
Okay. So over here, this is like how the transformers are working, and I have shown this particular thread earlier as well. So what I have mentioned, what I have explained. So this is having two main parts, like, say, attention block. Over here, if you are able to see, multi heads self attentions, no worry, do not worry about the multi head self, just focus on to the attention. So over here attention is there and MLP is there. Okay, and before this, what I'm having, the embedding. So we are talking about embeddings only. Narendra Modi is the Prime Minister of India. So these are nothing but the tokens what I'm having. So at this moment, I'm talking about the tokens only. Okay, I have not gone on to the attention mechanism. Okay, so that will come later. That will come later. So how this particular embedding is happening? Okay, so let me show you. So uh, once we are having once we are talking about the embedding, embedding is calculated based upon looking up the learned vectors. Looking up the learned vectors, I have highlighted this particular stuff. Looking up the learned vectors, okay, for each token into the spatial table called the embedding matrix. Okay, now over here, once we are talking about embedding, then there are two main phases, like training phase, okay, and the inference phase. Training and inference, so at the training phase, at the training phase, each token in the vocabulary, each token in the vocabulary is assigned a random vector. If we are talking about the bird, then 768 numbers, uh, random numbers are assigned. Each token inside the vocabulary will be assigned a random number. Okay, so during the training, what will happen, the model will update these particular numbers that is used in similar context and end up with the similar vector. Okay, so if the context is same, over here you can think in this particular way, like I'm having say vocabulary that is having, say, 50k words. So with respect to all of those particular 50k words will be divided into the features. So say we are having 768 features, 50k is the vocabulary. So 50k is the vocabulary, and this is vocab size. Vocab size, and it is given, say, 768 floating point numbers. random numbers are given. Okay, 768 random numbers. And why 768? These particular 768 numbers or features or dimensions, features or dimensions. This will come with once we are with the sophisticated programming models, like from these particular 50k words, these are the 768 dimensions in order to get the entire context from this from the given vocabulary. Okay, so in order to, you can say, proceed with a particular vocab, we will be having the certain features. With the help of that, we will be able to get the entire context from the given words. So 768 dimensions come from the sophisticated programming models. Okay, no need to worry about that. Now all of these particular 50k vocab tokens will be given random numbers with respect to the features what I'm having. Say if I'm having the 768 features or dimension, then 768 random vectors, random numbers are assigned. Now once these particular number are assigned, then the training will happen. I'm talking about the training phase once the model is trained. Okay, once the model is trained, over here I'm not talking about the given, you can say, context, given word or sentence. Say Narendra Modi is the Prime Minister of India. I'm not talking about that, but the entire vocabulary that is converted into into a matrix. And what will be the matrix size at that moment? Say 50k words are there in a particular vocabulary, and 768 is the feature. So this will be the size of the matrix, right? This will be the size of matrix. This is nothing but embedding matrix, which is, you can say, prepared at the time of pre-training. 50,000 into 768. Clear so far to all of you? Is it clear?
Yes, sir.
All of you, are you with me?
Yes, sir.
Embedding
Yes.
matrix. Okay. So now we got this particular matrix. Okay. We got this particular matrix, and during the pre-training, the model update these particular numbers. So at the time of pre-training, these assigned numbers will be updated. Updated, say, and how the updation will happen? The similar words, just have a look. Similar words used in the similar context end up with the similar vector. The weight which is given in a context, if the context is same, then the similar weight will be given, right? So the initial random numbers which was assigned, that will be updated. Now at the time of inference, at the time of inference, what will happen? The tokenizer convert a word into token id that I have given. Now what I'm talking about the Narendra Modi as the Prime Minister of India. Now the training happened and I'm having a matrix of 50,000 close 768. Okay, that matrix is there. Now from that embedding matrix, the IDs what I'm having, so these particular IDs is used to look up, just focus on to this line, that id is used to look up this vector in the embedding matrix prepared in this particular training phase, right? So the id is what I got, that will be looked up from the embedding matrix. So you can think in this particular way. uh, I was having a matrix, like, say, I was having, say, words, uh, This is India, and India. This is India and Prime and Narendra Modi say. So let me talk about. Let me mention it in this particular way. NA, REN, okay, DRA, DRA, MOD, I. Okay. So in this particular way, what I'm having say these 50,000, and over here I will be having say tokens. Huh? So one, two. I'm just mentioning in this particular way. So these are nothing but tokens, and with respect to each token, we will be having the floating points. Huh? Okay. Say 1.222, 2.333. Okay. 341.123. Okay. In this particular way, what I'm having the tokens. Huh? Tokens and their weights, what I can say, which was generated during the pre-training phase. Huh? Now this is the matrix for the entire 50k words in a particular model. I'm having 50k words or tokens, what I can say. Total 50k tokens are possible in this particular say BART based model. Although like I'm talking about the GPT-3. So inside the GPT-3, 50k is the tokens, and 12288 are the features. 12288. These are the features, and this is the matrix size for the GPT-3 model. Now GPT-3 is having this particular embedding matrix. Now what I will be having with respect to each and every, and this is say up to 50k, 50k. So all the tokens will be not I R E N D. Okay, tokens, and this is a first token. This is second token. I'm just mentioning. This is third token. This is fourth, fifth, sixth, seventh token, eighth token, ninth token, and 10th token. And in this way I will be having 50k tokens. 50k tokens, all the words in this particular, all the tokens in this particular model will be represented in this particular way. Say this, the, then, all the words will come over here. Those particular words will be converted into tokens, and with respect to each tokens, it will be having the different meaning, different, you can say, weight. So you can take it in this way. Sometimes it will be say minus. Okay, sometimes it is like this, and it will go up to 768. This is a first, and this is the 768 token. This is the 768 token. Let me show you this with practical. Okay, so over here, with respect to each and every token, I will be having 768, you can say, floating point numbers. Okay, and now if this is 50 cross 12288 matrix, and I'm having this particular sentence. Okay, Now what I will do, I will look up this particular sentence in this particular 50k cross 12288 matrix, and then I will be able to get, say, NA is there with the 33 token. Okay, and with respect to this I will be having these particular 768 floating point numbers. Now over here in this particular example, these 768 tokens, okay, these 768 tokens came from the embedding matrix. Okay, so I'm having Narendra Modi as the Prime Minister of India. Uh, these particular tokens are there. These particular tokens is looked up from the embedding matrix, and I will be able to get the token IDs. Fine so far? So in this particular way, the word embedding is happening. Any confusion? Anybody having any doubt? Is there any issue? Guys, are you able to understand? All
Yes,
of
sir.
you? Hardik, Raj, Neha, Shivam, Swati, Vikas. Guys, are you
Yes,
able
sir.
to get?
Yes, yes,
Okay, okay, okay. So I'm able to get the embedding, and because of this, just have a look over here. Okay, so the ID is looked up. Okay, is used to look up this vector in the embedding matrix. So I'm able to get the embeddings of each and every word which is given. Okay, so now I'm having the embedding. Now I'm having the embedding with respect to the the given sentence. Okay, so embedding is, you can say, is of two types, static embedding and the context rich embedding. Inside the static embedding, each word has the similar vector. Okay, so what is the meaning of this? So previously we have seen running. Okay, so running is a word, and if I'm giving static embedding with respect to the running, so each running, like running is used into four different context. So with respect to the each context, running will be having the similar vector. Okay, there will not be any change. That is nothing but the static embedding, that is not having the context in it. Once I'm talking about the context rich embedding, the word vector changes depending upon the context in context it appear in. So uh, at this moment, the embedding of the embedding will be changed. Embedding of the vector will be changed at this moment. So running will be having the different, you can say, vector with respect to the context. Okay, so over here, just have a look. Colorful Indian festival. And if I'm talking about the festival, so festival, it might be, say, festival can be anything. Okay, it may be Diwali, it may be Baisakhi, it may be Pongal, Bihu, whatever. So festival can be anything. Based upon the festival, and each and every festival, if I'm talking about the static embedding, so each and every festival will be having the same embedding vector. Okay, similar vector, each word has the similar vector. Okay, but based upon the context, over here, like colorful Indian festival, the the embedding, say, previously the embedding of festival was, say, A1. Now the embedding will be changed to, say, A2. Okay, because of the given context. Okay, and this is this is nothing but the attentions, like retaining the context. And over here I'm able to get wholly from the model. It is coming from the pre-training phase, like knowledge stored during the pre-training MLP. So from there we got the information as wholly. Okay, so this is an example like how embedding is happening, and how there will be 768 or 12288 floating point numbers with respect to a given token. These particular floating point numbers will be having different, you can say, values, and that particular value will be with respect to the different context. Okay, so it might be possible once I'm talking about even, then there will be the different floating point number. Okay, once I'm talking about the festival and the vector even is given, so that will be, or you can say weight even is given, that will be having different meaning. And once I'm talking about colorful Indian festival, then weight say A2 is given, that will be having the different meaning or different context. Okay. Now there is certain another stuff, like after the embedding, then it's the time for the positional encoding. So positional encoding, that is, you can say, that defines the position of each token in the given sentence. Over here, just have a look. What is the meaning of positional encoding over here? Okay, so an ARE and DRA Modi is the Prime Minister of India. Of this is nothing but the embeddings what I have given. Okay, and these particular embeddings are like, then what I'm having, the tokens with respect to each and every token. We am having the token ID. Okay, 45533. These are nothing but the token IDs. Then the positional encoding. So positional encoding is showing uh, the position of each and every token in a given sentence. Okay, so over here say n is onto the 0th position, r is onto the 1 position, and dra is onto the third position. So what I'm having, the position of each and every token is calculated over here, along with, and that will be, you can say, along with the token embedding, positional embedding uh, is also calculated, and it is utilized in order to get the correct, you can say, uh, context. Over here I have taken an example. So Modi is the prime minister and prime minister is the Modi. Okay, okay, although like these two words are like seems similar, okay, but look similar with respect to the model, but they can have different, you can say, meaning if we are talking about the English language or any natural language, basically English, Hindi. Okay, uh, so position matters a lot. So with the tokens, the position is also calculated um, for the given sentence, and that will be clubbed with the word embedding in order to get the correct, you can say, context from the given sentence. Okay, right. So what we have seen so far, say we are talking about, say, transformers, and transformers are having two main parts: attention and MLP. Okay, and attention mechanism, so it will retain the context. MLP is you can say, it will use the information. It will use the stored information, okay, or external information basically, in order to provide the output. Okay, now if a particular sentence is there, sentence is converted into tokens, and then tokens are converted into word embedding. Okay, and word embeddings, word embeddings, it will come from where? Embedding matrix. It will come from embedding matrix, and once we are having word embeddings, then positional encoding is done. Along with this, the positional encoding is done. Okay, now we are having the positional encoding. Okay, then what will happen? Just have a look. So over here, I have, you can say, taken the snapshot from that particular thread only, and this is the, you can say, Narendra Modi. This is the sentence, and this was the sentence, and sentences were converted into tokens, tokens, IDs, and then we are having the positional encoding now. Okay. Now, moving further, I just want to show you with respect to this. Okay. So, what we have seen with respect to the 2D space and word embeddings, I just want to show you something. So, this is a word embedding demo basically. Okay, and how these particular floating point numbers, over here I'm talking about the 300 features. Okay, so in this particular model we are having 300 features. With respect to the 300 features, what this particular model word embedding demo is try to predict the next, you can say, word. Say man is to king, and then say woman will be, I will submit it. Is it happening? Okay, so result is queen, and how we will be able to get, like, if we are having king, okay, and if we minus man from king and add it to woman, then what we will be able to get the queen. This is nothing but the mathematical notation. Okay, if say India is to Delhi, okay, then England is to submit it. I will submit it, and it will provide me the outcome based upon this, and how things will be calculated. Just have a look over here. England is to York. I don't know. It is not correct basically. Let me mention like this. New Delhi not found. Okay, this is not coming. I think it is not there in its memory. Okay, India cricket, and say Brazil. So what I'm expecting, football. Okay, football. And how it is coming? Cricket minus India plus Brazil equal to football. So from this particular, you can say, uh, matrix, what I'm having. So with respect to this particular matrix, this is into say 300 dimension. We are having 300 features over here. So just have a look: football, cricket, Brazil. So with respect to this, we will be these particular things are being, you can say, calculated. And say boy is to man, then say girl is to woman, basically. uh, Spelling is wrong. Okay, girl is to woman. And this we have seen uh, with the help of this 2D or 3D diagram. I have shown you this particular diagram, 3D embedding. Okay, so we were able to have the calculation. We we have like if man is to, you can say, king, then woman will be queen. Okay, so this we have done the calculation, and we were able to find it. So over here, with the help of this as well, we are able to get the outcome. So word embedding demo is nothing but it is going to provide us the informations once we are plotting uh, something into say huge dimensions, and those particular dimensions are, you can say, providing the points with respect to the features and the given uh, numbers or values, basically. So over here, age, gender and royalty, these are the features, and these are say vectors what I'm having, boy, girl, man. Okay, so with respect to these particular vectors, I am able to find the distance, and based upon that particular distance, I am able to predict the next word. We have seen, like, with the help of this word embedding demo as well, where 300 features are there, and with respect to the three features, we have seen like uh, if we, with respect to three features, like if boy is to man, then girl is to woman. We, and how this calculation is happening mathematically: boy minus man minus boy plus girl, that is equal to woman. Okay, so that is possible with the help of mathematical notations, and we are able to get the information. And uh, why we are doing this? In order to get the similarity. Okay, in order to get the similarity between the two words. Okay, in a particular sentence, if the two words are having similarity, then uh, they are closer to each other. Okay, they are closer to, or they are having the direct relation. Okay, so how we will be able to get the similarity? Just by calculating the Euclidean distance. Over here we have seen like the calculation of Euclidean distance. So with the help of Euclidean distance, we are able to get the understanding. Say if the distance is less, then definitely we will be able to predict the next word. Over here, say if we are talking about say boys distance with respect to man and woman, definitely it like boy will, the outcome from the boy will be man, not a woman. Okay, so these things are possible just because of the distance, and based upon the distance we are able to get the outcome. We are able to predict the next word. Okay. Now, I have mentioned that Euclidean distance is the perfect distance measure, but it is not utilized for the embeddings. That is, it can't be utilized for the embedding, because inside the embeddings we are trying to find the similarity between the two words over here, or two vectors basically. We are trying to find out the similarity. Okay, so for that, what we can have the dot product. Okay, so in order to get the similarity with the dot product, we are having this particular formula, x1 into x2 and y1 into y2. This is nothing but the simpler dot product formula, and this is the Euclidean distance. The issue with the dot product is that, like, all the points are starting, and these are, you can say, uh, these are moving in one direction only. Yeah. Over here, if we are able to see the angle, okay, the angle between boy, okay, the angle between, say, boy to man, over here, this particular angle, just have a look. If we are talking about this particular angle, okay, this angle, just focus over here. This particular angle, this is less. Okay, and the angle between boy to child, okay, boy to child is more over here. So with respect to this particular, you can say, dot product is providing a certain unmeaningful information. Okay, so dot product is fine over, you can say, Euclidean distance, but over here, the angle, this particular angle, uh, is providing wrong information between, if we are talking about the angle between boys to man and boys to child. So boys to child is more, however, like, boy is closer to child, but it is providing the wrong information. So in order to correct this, uh, what we are having, uh, we we need to do something, that all of these particular points will start from uh, center. So in order to start all of these particular points from the center, then what we need to do, we need to find out the mean and all. Okay, so at this moment, okay, so dot product was this. Then what we have done, the zero mean of 2D vector, uh, okay, zero mean has been performed. At this moment, all of these particular points are starting from the center. Okay, so this we have seen, like, how to calculate the mean and all. So we will be having this particular matrix once we are performing the calculations with of zero mean of 2D vectors. So that is fine at this point. Each and everything is fine over here. Like, if we are talking about, say, boy, and if we calculate the distance, uh, this particular angle, boy to man and boy to child, at this moment, this this particular, you can say, angle is closer. Okay, boy to child and infant is closer, this is more. So it provide a useful information. So that's why what we are having, the zero mean 2D vectors. Okay, so we have performed the mean of the dot product what we were having. But there is one challenge with this particular approach. One challenge, like, the distance from this particular point, this is not same. Okay, over here, say, from this point to adult, that is that is having less distance. Over here to the grandfather, that is having more distance, or man is having certain more distance. Okay, so the distance from the center is not same for each and every point. Then what we have done, we have normalized it. In order to have the same distance from the center, we need to do the normalization, and we have performed the normalization at this moment. Like, each and every point is onto the equal distance from the center. Okay, and that's what is preferred in order to, you can say, find out the distance between 2 points inside the machine, inside the GenAI models. Okay, let me explain it once more so that you will be having the better clarity. So we were talking about the word embedding. Word embedding is done like initially inside the pre-training phase we got the embedding matrix, and once a particular word is or sentence is given, that sentence is looked up from the embedding matrix, and then we will be able to get uh, the the matrix with respect to the given sentence. Say we are having only two features, or you can say with respect to these particular given words we will be having gender and age. Say gender and age is given. This is not the correct view. Okay, so the correct view, what it will be, correct view is this one. Okay, just have a look. So correct view is this one: man boy, girl, girl minus, so say man and man boy, girl and woman, four words are given. Okay, with respect to these particular four words, and we are having 300 dimension features. So these are the 300 floating point numbers. Okay, so onto the zero, you can say onto the zero, it is like we are having different colors. Okay, so these are nothing but the 300 floating point numbers with respect to women. These are the 300 different numbers for girl. These are the 300 different number for boy. Okay, and these are nothing but the floating point numbers. So we will be getting these 300 different floating point numbers with respect to each and every word which is given inside the sentence. Now in order to get the similarity, in order to get the distance, we are having Euclidean distance, that is providing the distance but not the similarity, so it is not used. Then we are having the dot product. Dot product is perfectly fine. Okay, but inside the dot product as well we are having issue that all the points are in one direction. Okay, in one direction, and the angles between the points is not providing the correct information. So what we tried, we have find out the mean, and then zero mean basically. Okay, what is the correct sentence? The correct sentence is unit vector. Unit vector is nothing. Okay, zero mean. So we have calculated the zero mean to the vector. Okay, zero mean. So at this moment, all the points will start from the center, and then from the angle we will be able to find out the distance and similarity. That is perfectly fine. But over here, the distance from the center with each and every point is not the same. So in order to do the normalization, we have normalized this particular zero mean 2D vector, and at this moment, like all of will be onto the equal distance. All the points from the center is onto the equal distance. Okay, so we have done the normalization over here, and this is what is being utilized inside the GenAI models. Okay, so we will be able to get the distance, or distance basically from each and every point, and with the help of this particular distance we will be able to predict the next word uh, in you can say high dimensional space. So that's what I want to cover in today's session. If you guys are having any doubt, you can ask. I think it, it is more clear at this moment. Guys, any input, anything that you are not able to understand? All of you, anything that is not consumable, or something is going above your head, you are not able to digest anything. Swati, Hardik, Gurmeet, Raz, Vikas, anything? Are you able to get?
Yes, sir, clear.
Okay. So, in next session, we will be having the discussion uh, on to you can say smaller thing from the transformers, and then we will proceed further with the rest of the stuff. Huh? Okay. And I will share this presentation. So try to run this particular code, which is given inside this presentation. And if you are having any doubt, you can ping me separately. Huh? Thank you.